Hi everyone, Jonathan here, and today I'd like to share with you how to tackle the sample lab test as well as how to prepare for your PLC lab test. So how we're going to tackle this is we're going to be using a SFC, a sequential flowchart, to plan your program before you actually start programming it on your TIA portal using Ladder. Now, the reason why we're doing SFC is because most of the time, and with respect to the sample lab test, a lot of the time our task is really sequential. Hence, using an SFC to plan it makes it so much more easier, right? So, things to expect in your lab test would be some missing parts in the HMI, human machine interface, and that, for instance, could be your missing operation lamp. You need to program the some HMI buttons to maybe light up, uh, you know, maybe some indicators, for instance, should something increase by 1, the HMI must show that it increases by 1, so on and so forth. So that's the HMI part of the program. The rest of it would be really your ladder programming and how you interface it to your HMI. So the lab test is about 30%, so let's go ahead and see how we can grab this 30% quickly. So I like to look at the paper for like about 5 to 6 minutes before I actually start writing out my SFC. So when I look through the paper, I try to extract as much information as possible, and I try to break them up into smaller bits so that I can form my SFC really quickly. So firstly, let's read the first instruction, which says that placing the workpiece at the sensor start should turn its indicator on, and this proves that the sensor and HMI works. Then removing the workpiece turns it off. So this is 10 marks. This is really simple. Try to get this really quickly because it's just your HMI programming. So you just have to go to your HMI and then select the sensor start LED, and then maybe modify some of the events such as the press and release. Then when you press, maybe you can say set bit, and then when you set bit, you can even add an appearance to make it green. And then the release would be reset bit, which means turn it back to logic 0, right? And then this one you can just ignore the color so that it will become gray. So this one's really quick, 10 marks. And then again, it has nothing to do with the SFC here, it's really HMI. So then the next one, it says before operation begins, the operation lamp is red and operation lamp is missing from a HMI. You have to create it from scratch. So this one again is another 10 marks that you can really grab it really quickly, because if you've looked through lab 5, you would have learned this and it's really quick. So like I mentioned, operation lamp is red and then it's missing from HMI, so you have to create it. So that one, it's really quick as well. Again, it's HMI based and nothing to do with our ladder program. Yeah. So then the next one, it says when workpiece is placed at sensor start and start button is pressed, operation lamp turns green and stays green throughout the process. Okay, so this is where we have to start writing our SFC, right? So here, over here, I have started off with a first scan. Why first scan, you might ask? Well, because my step 1 will be the initialized state. So initialized state basically means do nothing, but the machine is on. So for instance, when you turn on your computer, right, you don't straight away go into Netflix and it starts playing a video. No, you go to your laptop, it opens up the home screen, and then it stays at the home screen, right, before you can click on your applications. So that's basically initialized. And to get to this state, basically you will like on the CPU, and when you on the CPU, you need to like start this S1. So what is the so-called condition to start it? Well, it will be your first scan. First scan, for a quick little revision, is basically a first scan is basically another contact. It's a NO contact, normally open. And what happens is that the moment CPU turns on, so when CPU is on, so the moment you press the CPU and it starts, your first scan will give logic 1. Means from NO it goes to NC, which allows current to flow. So that's basically your first scan. And that's a really important concept because one scan cycle only happens one time. That means each time you off your CPU and then you on again, that's the first scan cycle, right? So that's why we need this first scan to start our initialized state. Okay, and so back to the lab again. So it was saying when workpiece is placed at sensor start and start button is pressed. So the keyword is AND. So AND means a AND logic. So we have a sensor start and start button, start push button. When both of them are on, then you can move on to step 2, right? So step 2, let's continue reading the lab sheet before I start with step 2. So it says here, number 4, forward/reverse arrow indicator turns green whenever the conveyor moves in the respective direction. Otherwise, they are grey in color. So again, this is another HMI modification. So you just have to modify these two indicators. It's really simple. Okay, so now number 5, this is where the sequence starts, and it says forward for 7 seconds. So what does that mean? It means remember that we were still in our step 2. Sorry, we haven't started our step 2 yet, but they said that it's forward for 7 seconds, then it stops for 10 seconds for painting to take place, and then this other indicator called spray paint should be turned on and it's blue in color again. So when they say blue, they mean that you have to make sure it shows a blue color when it's on. So that means HMI modification again, right, during this time. So after that, it reverses until workpiece reaches sensor start. So now this one's 20 marks. So this one is where people will start to struggle. So let's go back a bit. Let's go back to our step 1 and then our transition 1, T1, where we said sensor start and start push button must be on. So once these two conditions are met, we can go to step 2. So at step 2, what happens? Well, it says that in the next page, it says that your operation lamp should be on, and it should on as in, it should indicate that the process is ongoing, and then it says that it needs to stay on, right? It needs to stay on throughout this process. So after that, you have a motor forward, right? Because they say here forward for 7 seconds. So motor forward on, and since they say it's for 7 seconds only, we must include a timer. So this timer T on 1 is also part of the outputs, and this 7 seconds will be our transition 2. So it's a condition to go to step 3. So now at step 3, the spray paint is on. So that means you have an indicator as well, right? So that should turn on as well. And again, be sure that it's blue in color. So that's again your HMI stuff. So spray paint on, and then on for how long? Well, they said for 10 seconds because that's the time the motor forward stops, right? Notice that I didn't include another motor forward off here. Well, that's because once I go from step 2 to step 3, the whatever that's happened in step 2 will not happen in step 3 unless I write it in step 3. So as you can see, there's no motor forward here, right? So motor forward is considered as off in step 3. So this spray paint will turn on again, TON2, 10 seconds. So that will be our transition 3, 10 seconds. So after 10 seconds, then we can go to step 4. In step 4, the motor reverse is on, and then on for how long? Well, it's on as long as possible until it reaches the sensor start. Okay, once it reaches sensor start, then motor reverse is off, right? So that will be in step 5. So step 5, your operation lamp is off, and then your remove painted part, or that's what they say in the question, remove painted part. Over here I say remove paint. It starts blinking for 0.5 hertz. Now note that it's blink 0.5 hertz means you can use the preset clocks, right? So that's when you are setting up your first scan you would have also set up your preset clocks as well. So you can use this to blink for 0.5 Hertz, right? And then the next transition will be T5, and that will be when the acknowledge push button is pressed, you will stop the blinking, and then your counter will increment by 1. And this incrementation, again, you must display on your HMI as well, right? So then 9 would be the process can be repeated without problems. So what does that mean is that after step 6, you should be able to go back to step 1 again, and then you can repeat the process one more time. So that means you can keep counting the number of painted parts that are being painted, right? So that's what they mean by the above process can be repeated without problems. Then the number of painted parts should be displayed correctly on the screen. So that was what I meant by the increment should be displayed as well. So that means after I paint 3 parts, then it should show 3 parts on the HMI screen itself. Yeah. So then they also mentioned that the number of painted parts can be reset at any time using the clear button. Well, the clear button is also a HMI button, and you can also interface it to your counter as well, which I didn't include because that's really in the modification part of your program, which I'll go through in a separate video. But for now, this is our plan and it looks pretty solid. Take note that we have a first scan, and then we have step 1, 2, 3, and then whenever I'm in step 1, whenever I'm in step 1, the only thing it's going on is initialization, so it's nothing much, right? And to get to step 1, there are a few different conditions. Either it could be first scan, which means the moment I turn on my CPU, or let's say I've already finished the entire process one time. So let's say I'm at step 6, it will go back to step 1. So that means I have to link it back to step 1, which also means that let's say I have the first scan here, and then let's say this is the next step, which is step 2, right? Then this is my step 1. So this is one of the conditions, right? First scan was one of my conditions. Another one of my conditions would be step 6. Once I complete my entire process, I can go back to step 1. That's one of the other conditions as well. And again, like I said, it's always the previous step, which was step 6, that powers the current step, which is step 1, and then the next step, which is step 2, will kill the current step. Right? This I will explain once more in another video where I actually simulate the entire program. But for now, I hope you understand the SFC and how I wrote it, because this is really going to help simplify your program later on.